Today's lesson will be on factorising algebraic expressions. So we've got a few learning goals for today. Our first is to be able to identify that factorising is the reverse process of expansion. Our second is to factorise algebraic expressions in order to simplify them. And our last of all is use expansion to check our factorisation. Okay, so just a little bit of a refresher on highest common factor. So we've done this in a previous video. So a highest common factor can be a number of things. So the highest common factor could be a number. So for example, the highest common factor of 9y plus 6t. So probably you could do that in your head, and our highest common factor would be 3, because that's the highest number that we can divide into both 9y and 6t. Our second one, our highest common factor could be a pronumeral. So for instance, in our example, we've got x plus 5x plus x squared. So we have to find out something that they can all be divided by. And the answer to that would obviously be x, because we can divide all of those by x. And last of all, our highest common factor could actually be a product that's made up of numbers and pronumerals as well. So for instance, if we were trying to find the highest common factor of 2y squared and 8y, our highest common factor would actually be 2y, because 2y goes into 2y squared, and it also goes into 8y. So you can see there we've got the number and the pronumeral. Okay. So factorising, we've done a lot of work on expansion in our previous videos, and we've spent time expanding brackets and things like that. Factorisation is kind of the opposite. So when we factorise expressions, we have a few steps to follow. So the first thing we do is find the highest common factor. So once we've found the highest common factor, we write it outside the brackets. Inside the brackets, we write the expression as it was, and we divide each term by the highest common factor, and our answer to that will be our factorised expression. And then if we're unsure if this is correct, or just to double check, we'll then expand it to see if we get back to our original answer. So if you're in a test situation, if you have to factorise something, I would definitely suggest checking your answer by expanding it, just to make sure that you got the right answer. So for example, we've got 2x plus 10x. So the first thing we're going to do is find our highest common factor. So our highest common factor of 2x squared and 10x. So what can they both be divided by? Well, they can both be divided by 2x. So we're going to write 2x, which is our highest common factor, outside the bracket, and inside the bracket we're going to write our original expression, 10x, and divide each of our terms by the highest common factor. Okay, and then we'll solve that, and that will actually give us our answer. So 2x in brackets, 2x squared divided by 2, well, these will cancel out, that will cancel out, take 1, so we'll just be left with x plus, so the x's will cancel out here, 10 divided by 2 will leave us with 5. So our final answer would be 2x times, in brackets, x plus 5. As I said, we can check that using expansion, so over here we can check x plus 5. So we're going to apply it to everything inside the brackets. 2x times x is 2x squared. 2x times 5 is 10x. And that's what we started off with. So we know we found the right answer there. Okay, so we've got a few worked examples. So to start off with, we're just trying to find the highest common factor. We're not going to expand or anything. Just find the highest common factor. So our highest common factor of 6a and 18ab. Well, our highest common factor is going to be 6. So 6a can be divided into 6a, and 18ab can also be divided by 6a. For our next one, 3x squared and 6xy, our highest common factor is going to be 3x. So 3x squared can be divided by 3x, and 6xy can be divided by 3x as well. Now our last one's a little bit tricky. You may look at that and be like, oh, I don't know. But what can they both be divided by? Both of these expressions can actually be divided by out the bracket, a plus c. So that would be our highest common factor in the case of these two examples here. Okay, so now we're actually going to do some factorisation. So we're going to factorise each of the following expressions. So I'm just going to start here. So a, we've got 40, take 16b. So we have to find our highest common factor. So our highest common factor of both 40 and 16b is going to be 8, because both of those can be divided by 8. So we're going to write that out the front of our expression, 8, and in brackets 40 divided by 8, take 16b divided by 8, close bracket. Okay, so 8, 40 divided by 8 is going to leave us with 5. Take 16b divided by 8, it's going to leave us with 2b, close bracket. And that would be our answer. So again, we're going to check. So we're going to expand what we had there. So 8 times 5 is going to give us 40. Take 8 times 2b, 16b. Yep, so we know we had the correct answer there as well. Okay, for b, we've got negative 8x squared, take 12x. And we have to find our highest common factor. So straight away, we can see x is obviously going to be our pronumeral, and we also have to find our number. So it's going to be, in this case, we could do a negative or a positive. It's really up to us, whatever we would like. So we're going to make it ours. Negative 4x is our highest common factor. So at the front of our brackets, negative 4x, negative 8x squared divided by negative 4x, take 12 4x. Okay, so a negative divided by a negative is going to be a positive, so our answer here is going to be 2x. A negative divided by a negative is going to be a positive, and it's going to be 3. So that would be our answer there. And we can expand over here to check that we are, so we'll check negative 4x, 2x plus 3. So we're going to expand. So negative 4x times 2x, so a positive times a negative is going to give us a negative 8x squared. Positive times a negative is going to give us a negative. Negative 4x times 3 is going to give us 12x. And look back at our original question. Yep, we've got the same. So we know that our factorising answer here was correct. C, we've got to find our highest common factor. So again, this is one of the ones, it's a bit tricky. We've got to look. So what would our highest common factor be? So we've got 3x plus y plus x plus y. And our highest common factor is going to be our brackets. So it's going to be x plus y. So we're going to write that out the front. We're still going to keep the brackets, x plus y, and then inside the brackets we're going to do 3x plus, let's rub that out. Sorry, rub that one out. Okay, so that should be in brackets, x plus y divided by x plus y plus x plus y divided by x plus y. Oh, brackets here as well. It's a lot of brackets, and then obviously we can just simplify it there. So x plus y is on the outside, and our inside brackets we've got, so this will just cancel out, and we'll just be left with 3, and this will cancel out, and we're left with x. So our factorized version would be x plus y in our first brackets, 3 plus x in our second brackets. And again, if you want to check whether that's correct, you can expand that out and see if it is, which it will be correct. Okay, for D, we've got 7, take 2x in our first bracket, x, 7 take, 7, there we go, rub that one out, 7 take 2x in our second bracket. So our highest common factor, what can they both be divisible by? Well, they can both be divisible by 7 take 2x. So again, we're going to write our highest common factor outside in brackets, and then rewrite our expression dividing each term by our highest common factor. So 7 take 2x divided by 7 take 2x, that's all in brackets, take x, 7 take 2x, divided by 7 take 2x, also in brackets. And from there we can simplify. So 7 take 2x divided by 7 take 2x will leave us with 1. So 7 take 2x, brackets, 1. Again, another mistake. I'm racking up the mistakes today. Okay, so 1, because 7 take 2x divided by 7 take 2x is 1. second half, we've got 7 take 2x divided by 7 take 2x will be 1, which will leave us with x. And that will be our final answer there. So 7 take 2x multiplied by 1 take x would be our factorized version. And again, you could expand out your brackets and compare it to the first one just to make sure you got the correct answer there. Cool. So that's all we've got for our video today. Make sure you have done these worked examples in your book, copy down the notes, and as usual, if you have any problems, don't hesitate to ask me.